So you guys tell me, what do you guys want to do? Nobody's put anything in the comments. We don't want to do anything. We've already done an hour of calculus, except for Donovan. And so where do you guys want help? All right, I'm gonna start calling on you. Madison, which one do you want to see? Okay, part F on BC3. All right. And Sarah, they all have a tabular piece to them. So if there's a part that you want that's weirder and uglier than others, tabular just means you're getting all the stuff from the table. Okay. So Paulina says she wants to go over BC3. I'm going to start with F because that's what Madison asked me for, but then I'll go back through the rest of BC3 and then we'll see what we have time for on any of the other ones. Okay, does that sound good to everybody, hopefully? Okay. All right, so I'm going to set those there. Hopefully I don't lose them. All right, so I'm going to start with F. F does look particularly nasty. Remember, you are allowed to have your orange sheet out. I wouldn't bother rewriting your orange sheet. You've got your orange sheet. I would make sure you know where your geometric, your p-series, your ratio test, and your alternating series. Those are the 4 you are responsible for this year. Okay. All right. So, no, I do not. Okay, so I'm going to BC3 part F. Okay, so it looks super scary because it says for x greater than 6, f prime of x equals 100 over 2 to the x, and we're supposed to find the summation from n equals 6 to infinity of a sub n. All right, if I don't know what that means, okay, I know what summation means, I could start expanding that. Okay, so that's what I'm going to do. They did tell me in the stem of the problem that this series is defined and a sub n equals f prime of n. So I know that f prime of n, they told me in this problem, is this. So this is basically getting plugged in, okay? So really, if I stepped through it, it's really that this guy equals, and you don't have to necessarily show this, but equals that guy, and then I can substitute this guy in for that. So 100 over 2 to the n. Okay. Now, I still don't really recognize that as geometric or p-series or alternating. It doesn't look alternating, and it doesn't explicitly say to do a ratio test. So, and it actually wants me to find the sum of the entire series. That's actually wanting me to find the sum. So there's actually only one series that I can find the sum of, okay? So the only series I'm actually able to find the sum of is the geometric series. And you should have that formula for the sum on your orange sheet. It should be there, okay? If you hopefully have your orange sheet in front of you. So I'm going to expand this a little bit, because even if I didn't think about this find the sum part first, if I started expanding it, I might recognize what's going on. So I'm going to go out like 3 or 4 terms. So I know if I have to start by putting in 6. So 100 over 2 to the 6th plus 100 over 2 to the 7th plus 100 over 2 to the 8th plus dot, dot, dot. Definitely looks like it's growing by a ratio. So remember, in a geometric series, and this goes back to algebra, like algebra 2 stuff, I have to take the second term divided by the first term. So the second term divided by the first term, which really means that I am multiplying by the reciprocal of the denominator. Okay, which these guys are gone, and ooh, that goes into that, so I'm down to that my ratio is 1/2. Okay, so that's part of the problem. I know what my ratio is. I know that my first term, or my a sub 1, has got to be that, okay, because I've actually plugged in. So I'm going to need all of that when I actually try to find the summation, because I need to use the summation formula. So the summation formula, remember, is your a sub 1, or a, over 1 minus r. That's going to get you the sum of any geometric series. Only geometrics does this work for. So I'm going to write out the proper mathematical notation. N equals 6 to infinity of our a sub n is going to be, I plug my first term in, 100 over 2 to the 6th over 1 minus 1/2. And I am going to stop right there. Okay. Now remember, these guys from the released exam, or the guys that are putting this, there isn't points on these. They're just showing good calculus. You would want to do the best you can. I mean, you're going to try to do the best you can and get as many points as you can on every problem. Okay. Any questions on that part? It wasn't nearly as bad as it seemed, right? Once we kind of started doing it. And sometimes you just got to start trying to do something. All right, and get something on the paper. All right, I'm going to go ahead and go back to part A. And I don't know if you guys have noticed, but in the little Dropbox folder that they have out there, about a day later, they do put the answer key out there. I encourage you to look at it. It's actually stepped out pretty well. Though this one on part A was so crazy, and I think they've got a typo because they've got a double integral. And you don't do double integrals till Calc 3. So that's not us. And I think but it's the same integral twice, so that's why I think it's just a typo. I have found a few little minor typos in their key, so, but they really do step out like every single step. So, but this one, I thought the stepping out was a little bit too much. It confused me more than anything else. So I kind of did it my way. I know I've got to evaluate from -1 to 0 of f double prime of 1 minus 3x. All right, so we're going to do u substitution because there's an inside. This is definitely an inside function. I'm not going to do all of u substitution. You guys have been doing u substitution for 2 years, or at least a year and a half. So we're just going to do as much as we need to figure out what I have to actually add in there, right? So du equals -3 dx, which means we know we're missing a -1/3. So I need to just put a -1/3 in front. Okay. As we've kind of listened to the videos a little bit, we have learned that it is poor notation. If you actually doesn't matter because we're going to go ahead and we're not going to show the u sub, so we're good. Never mind. If you do choose to put the u in there, you do need to change these limits, okay? And I think I did that, but it's not going to matter. I can do it this way. So -1/3. When I integrate f double prime, I get back to f prime of whatever the inside mass is, okay? And I'm going to go from -1 to 0. All right, so we've got -1/3 f prime of, let's see, I'm going to put in the 0 first. So we've got 1 minus 0, which is just 1, minus f prime. I'm going to put in the -1. So let's see, 1 minus -3 times -1 is +3, so it's going to be f of 4. Okay. Well, I can't leave it in f's, so I need to figure out where my f's are. So that's where your table comes in. Good news, the table tells us f prime of all of these values. So I know I need f prime of 1. So I'm going to find that x value and read off this y value and substitute it in. So -1/3, technically I should have equal signs. -1/3 of 62 minus, and then I need f prime of 4, 15. And once I got that substituted in, I stop. I do not do anything else. Okay? Any questions on part A? Okay, let's look at part B. So, put it in the chat. When I see an infinity up here, what do I, or you can come off your microphones up. It's everybody put it in the chat. What am I going to need when I have a number to infinity? It's a BC thing. We do need a dummy variable. Connor's right. We need limit as b approaches infinity. What's that stuff called? Do you guys remember? It starts with an I. There we go. Yes, integral starts with an I. It's actually an improper integral. There we go. All right, so we do need an improper integral, okay? So that's what we're doing. And remember, this is the thing that seems so silly that we do this, because we all end up plugging the infinity in again, but it's because of the theorems and stuff that are behind it, which I'm not getting into now. We're just going to deal with the process. So we're going to just, we're going to use improper integration, and we have to do the limit as b approaches infinity, that stuff, okay? And we need all of that structure there. So I know I have to switch this to improper, so I do limit as b approaches infinity from whatever number they give us to b, okay, of f double prime of x times sine of f prime of x dx. All right. These guys that put these problems together, they're incredible, because look at, they just got an improper integral, but look at what's inside of it. Now we've got to use substitution plus trig, okay? So they're putting a lot of concepts together in one problem. And you're going to want to you're going to want to bet that they're going to do this to you this year, because this isn't something that you're just going to plop into, like, not Desmos, what's the other one? Photomath, or one of those that you can just get the answer to. So you're going to combine concepts like this, and we don't know which concepts are going to all be like, it's like they're app smashing things together, okay? But they're calculus smashing instead, okay? I just invented that. Wasn't that good? All right, so your u is going to be the inside function. So u is f prime of x, which means that du equals f double prime. And actually, I've been using that in blue. And I know this isn't your color coding, but it's mine. Equals f double prime of x dx. I'm going to go ahead and show it on this one, because I think you kind of need it. So look at, there's my blue. So I have everything I need for my u. Actually, I'm probably not going to, I'll show it. Yeah. And how would they show that? I think we're going to use the axis. Okay, so this is going to be a little bit weird notation. It's coming up. So we've got the limit as b approaches infinity. Because I'm going to put my u's in there, I'm going to say that x, I'm not going to change these variables. So I'm going to be explicit and tell them that those are my x variables, because I'm really not supposed to do this. I'm really supposed to switch them to u's. Oh, du, not dx. Okay. But I'm going to leave it in terms of x when I go back, okay? So I'm going to integrate. So when I integrate sine, I get back to negative cosine. I still have the limit as b approaches infinity of negative cosine. Instead of writing u, though, I'm going to go back to my f prime of x. And then I don't have to write the x equals anymore, because I'm back in the right variable. All right, and then I've got the limit as b approaches infinity, and I'm going to go ahead and plug in my b and my 5. So negative cosine f prime of b minus negative cosine of f prime of 5. All right, and then this is where this thing gets a little bit crazy, okay? First of all, I know I could probably find f prime of 5, so I'm going to go back and look at that table again. F prime of 5 is equal to 12, so I get to plug that in. So I know that this is actually going to turn to positive, so plus cosine of f prime, or no, of just 12. We got rid of the f prime. All right, then I've got to figure out what on earth is going on here, okay, for this little piece. So, because I still have, I still got to find the limit of this mess. I'm going to go ahead and write it out, because I'm not quite there yet. Negative cosine f prime of b. So, early in the problem somewhere, where did I see it? Oh, it's up in the stem, because I didn't really read you the stem. It says that there's a horizontal asymptote at y equals 0. Okay, so the derivative has a horizontal asymptote at y equals 0. Well, that means that the limit that we really can't get any bigger than 0. It has to do with the limit here. So it implies basically, so this part here comes from the horizontal asymptote, okay, equaling 0. So basically what happens is I can plug a 0, not that whole thing, I'm sorry. Just this piece of it, just that piece. So I basically get to plug a 0 in for that. Okay, and it's coming from that funky asymptote that they gave us at the beginning. So the limit as, and we're applying this limit now. So I'm just writing, I'm not using the limit anymore. So I've got that we now have the negative cosine of 0 plus the cosine of 12. Which I know the cosine of 0, if I do know the trig, I would use it. The cosine of 0 is just 1. This we can't calculate without a calculator, so I wouldn't do that. I would just leave it. Remember, the test this year is written so you don't have to use a calculator. All right, I think I was good up until like this weird step right here, right, with this horizontal asymptote goofiness. Remember, if you got that far, you would still get some points. And we're going for at least 40%, so you want to try to be getting like, 1 point a problem, okay? If you didn't get that last little bit, that way, unless you're really going for the 5 or, the 27 or whatever it is you can get that's the highest, it's only 5. Okay, next part. You get to write an equation of a tangent line and then use it to approximate. So do you see how they just jumped from, and they could do this to you in the test. They jumped from A was an AB concept, super basic AB. So the AB kids would get that one. This is definitely a BC concept with the improper integral. Now we're jumping back to AB, and we're still using a stem that is a table, okay? And you'll notice that there's more than 4 parts or 3 parts because we're anticipating that question number 1 is going to have 6 or 7 parts. And they've stated, I've watched all the webinars, they've stated in the webinars there are more parts there than you need to answer to get a 5, okay? So please try to get, if you can get half of it answered. The more you get answered when you make mistakes, the better off you are. But you can still totally pass it without answering everything, okay? But there is going to be an emphasis on the actual BC stuff. So something like this improper integral, highly likely to see because that's a total BC thing, okay? All right, let's look at this one. Right equation of tangent line at x equals 5, so I need a point and I need a slope. They do tell me up in the stem of the question that I have this point f of 5 equals -6, and I happen to be needing that. So I know that I have the point 5, -6. I do need to find the slope at 5, so I'm looking for f prime of 5, and gee, I've got a table. And they tell me f prime of 5 is 12. I just get to use that number out of the table. All right, so I'm already ready. Oops. To put it into equation of a tangent line. So earlier we saw one, I think it was earlier in AB, where we didn't have to change that from a y. They are talking about approximating to f, so we will change it in this one. It's just the nature of how the problem is stated. So y minus my y value -6 equals my slope 12 times x minus 5. Double negative goes positive. Because I am going to have to approximate, I'm going to move this over. So y equals 12x minus 5 minus 6. And then I would probably, I don't know if it stated it somewhere. Did it state it somewhere? It did not state it anywhere. Usually in problems like this, they make a statement in here that y equals f of x. If that's not there, you might want to make that statement right in here, let y equal f of x, just because it's proper mathematically. Typically, the problem states that. They may have just, because again, they're just humans like if you've been watching, it's Uncle Tony and Uncle Brian. Sadly, I'm too old for them to be my uncles. They're human just like us, and they make mistakes when they're writing the problems, and they may have just left it and neglected to put that in there once they knew they were putting this little stem in there. So it's okay. So we're going to say that f of 5.1 equals 12 times 5.1 minus 5 minus 6. It's better on these not to distribute because look at what's going to happen. You just get your 0.1 in there. But again, you don't need to keep going. You're going to stop right there. Okay? If you really, really need the answer, it's negative 4.8. All right, how are we doing on part C? Okay, let's keep going. We're going to do part D. Okay, so part D, now we're jumping back to a total BC thing. We're going to do Euler's method. We're hoping we see Euler's method, right? Because we like Euler's method. It's super, super fast and easy. The way they're setting up their Euler's method, just a little different than ours. I did not watch their lesson on Euler's method, but they do kind of this crazy little table thing. So, but it's good. So let's go through it. So you'll see once I do my work, if you compare it to theirs, you'll kind of see where their table matches up with what I do. Okay. You have to start with a starting point, and it says we're starting at x equals 5. In the problem, remember, it says right here what that is. So we're going to do f of 5 equals negative 6. We have to approximate f of 3. It says we're only using 2 steps. So we're going to go down to f of 3. If we're only using 2 steps and we're starting at 5, that means that my middle step has to be 4. Okay. All right. So when I'm doing Euler, I repeat the y value from the previous plus this part in here is the slope, right? It's the f prime or the dy dx or whatever it is. So I need to find of the previous. So in this case, it would be f prime of 5, the previous one. So I do know f prime of 5. We should have it memorized almost. We've used it so many times in this problem. It's 12. So I'm going to do 12 times, and this is the change in step size. So my step size is, look at what it's just a 1 in between there, right? So step size is 1. If I didn't have to use it again, I probably wouldn't do the full calculation. I'm going to have to use it again, so I probably will do the full calculation. So I'm going to say it's negative 18. Now I take this guy and I repeat him. So my y value from the previous plus the slope of the previous, which means I need the slope. So this would be f prime of 4 is what I have to put in there. My 4, because I'm using that x value there, f prime of 4 is 15 times my step size. And then you stop here. You don't need to do that calculation. You're pressed for time. You want to still try to pick up some more points. So you can get the 5 instead of the 4. Okay. If you must know what it is, it's negative 33. Remember, if you messed that up and you had this right, you just lost the point. So you want to make sure, that's why we stop here. Okay, don't keep going. All right. E is one of the craziest things you're probably ever going to see. Okay. It's a really interesting connection between AB and BC. Take a second and just skim that over. Okay, so use a left Riemann sum with 4 subintervals indicated in the table to approximate the arc length of f of x over the interval from 1 to 5. So I have to use arc length and a Riemann sum. All right, totally crazy looking. Okay. I'm going to go ahead and write the structure of it out for you, as well as writing the substituted answer in, just so that you can kind of see that structure. I will try to squish it into the space that I have there. So I am going to write tiny. I'll try to use a color that, in this case, I start running into stuff I haven't used in that area yet. All right, so remember arc length, which there's a lot of different variables. They called it an L. Doesn't really matter. We know we're going from 1 to 5 of the square root of, and remember, it's 1 plus the derivative squared with a dx after it. So I'm going to expand what that's going to look like. It says we only need 4 subintervals, okay? And a Riemann sum, remember, is basically areas of rectangles, especially when it's left. So I need a base and I need a height. Well, my base is going to, or my height is basically the distance in between. This is going to give me the calculation of the base part of the rectangle. Okay, so wait till you see what happens with this. So I've got a plus, a plus, and a plus. I'm making space for 4, so 3 plus signs. I'm going to kind of go back to my table a little bit. I'm going to do, it said we wanted 4 subintervals. So 1, 2, 3, 4. I am supposed to be coming at it from the left side. So I know I start with this height here, okay, when I plug in. But I'm really plugging in, when I plug, this actually, I'm starting with that x value there. Okay, so I'm going to plug that into my arc length formula. So square root of 1 plus f prime of 1 squared, that's the height, times this distance in between, which just happens to be 1. I'm sorry for all the scrolling. I should have brought it down. Okay. All right, I'm going to do that same thing again. So I've got my arc length formula, 1 plus f prime of, and my next value in the chart is 2 squared. And then times the distance in between is still 1, 2 minus 3, or 3 minus 2. Then we've got the arc length, so 1 plus f prime of, this x value is 3. And then I have to square that and multiply by the distance in between, which again is still 1. Okay. Finally, I'm going to get my last one in there for the 4. So I've got my arc length formula, 1 plus f prime of 4 squared times the distance in between, which still happens to be 1. Okay. Now, this is kind of writing, they call it the sums of the, I can't remember the word. I probably have it written somewhere. But you have to show a structure. You don't necessarily have to show this, but you do have to show sums of products. You have to show a sum of products, okay? Whether you show it with this structure in it or not is up to you. You don't have to do that. We could have gone right to plugging the y values in there like I typically do, okay? But I know some for us, this might help. I'm not going to write the times. Oh, I'm going to write the times once so that way you can see it. So 1 plus, I do have to put the evaluation in there for f prime of 1. So I'm going to read those values out of the chart. So now I'm going to put in that 62. And we've got to square it times 1 plus. And I'll show you why I'm doing the times 1 here in just a second. The f prime of 2 looks like 30. So 30 squared times 1 plus the square root of 1 plus f prime of 3 is 20 squared times 1 plus the square root of 1 plus and f prime of 4 is 15 times 1. All right, if you had just done this line here, you would have earned the point. So you didn't have to do this line above. But you have to show, you need to show the times 1. So you have a sum of products, okay? Because that's where you're getting the point from. Because this can be your sum of products and your approximation. And there's another type of one probably making, they have an equal sign there. But what I really should have here are approximately symbols, okay? You can have what they call a linkage error if you don't have an approximately there, okay? Have to plug a battery in. How we doing? We all still there? Okay, any questions on that one? All right, I think that took care of all parts of BC3. All right, and we've got about 20 minutes left in our session because I think that my brain probably hurts enough after 2 hours of calculus. So you guys tell me what parts of either BC4 or BC5 do you guys want to do? You tell me, okay? There's particle motion in here. There's some related rates with an intermediate value theorem in there. There's more Riemann sums. There's a L'Hopital's rule. What do you guys want to do? Give me a part. Crickets. Or are we done and our brain hurts? Part C and BC5. Okay. So BC5, part C. Oh, that's a good one. This is a BC level question. Okay. All right. BC5. So there's BC5, and we're going to do part C right here. Okay. All right. So we're looking at something like that. It's definitely not a U sub problem, but it looks like a product rule. So I'm going to have you type it into the chat. When it looks like a product rule, what do we need to do to integrate it? So everybody put it in the chat. If there's nobody knows what it is, the delay is really bad. There we go. Connor's got it. Anybody else got it? Or are we all going to copy Connor's answer? All right, we do have to do integration by parts. Okay. It's, or what we remember, we called it ultraviolet voodoo. Okay, UV minus DVU. Okay. So I'm gonna make my little chart over here. So my U and my DU, and then I've got my DV and my V. You guys remember LIATE? Okay. It was logs, inverse trig, algebra trig, and exponential. So really what we're looking at here is, because I don't really have all those parts, but I do have something algebraic, and this helped me pick my U. So I'm going to put the algebraic piece in my U. G double prime would be very easy to integrate, so I would want to put that in my dv. So dx, and then my dv is G double prime dx. Well, I know when I integrate that, I have to get back to G prime. Okay, so it's U V minus the integral of V du, ultraviolet voodoo. All right, and we're going from 1 to 8. I do need to make sure that I put the 1 to 8 in this UV part because it's already kind of been integrated. So I've got U is X, V is G prime of X, and I'm going to go ahead and put the 1 to 8 in there, minus from 1 to 8 of V, which is G prime of X, and then du, which is just dx. I'm going to integrate this piece at the back. I'm not plugging in anything yet. When I integrate G prime, I get back to G. All right, I am ready to start plugging in. So I'm going to start plugging in my 8 times G prime of 8 minus 1 times G prime of 1 minus big parentheses because we don't want to have a sign mistake in here. G of 8 minus G of 1. I'm going to go horizontal. I know that's not good, but I'm going to go horizontal. All right, so somewhere I must have this information. Oh, what do you know? We've got a table, okay? We've got to go G prime of 8. So I'm going to go to my table and I'm going to go find my G prime. G prime of 8 is 1. So I have 8 times 1 minus, I really don't need the 1, but I need G prime of 1 in my table. G prime of 1 in my table is negative 4. Minus, and still a parentheses, G of 8. So I got to be careful. I'm going to G of 8 this time is 16 minus G of 1 is 5. And again, now that we've got those plugged in, we stop. We do not go any further. Please don't, you guys. It's not worth the dropping your 5 to a 4, your 3 to a 2. Okay, don't let it bother you. I know it bothers us, but don't let it bother you that we're stopping right there. Okay, I shouldn't even give you the answer, should I? But it's 1. All right, we still got some time. That didn't take us that long. Is there any others in any of these parts that you don't know how to do that you want me to show you? Okay. So good question, Sarah. Do you see how right in here you're multiplying a variable by a variable? When you have, there's no keywords in the problem. It's a variable times a variable. It looks like if we took away, if I took this away and it looked just like that, we would think product rule. So if it looks like a product rule and a U sub does not work, okay, then that we know it's an integration by parts. Does that make sense? Okay. And I know that was something we learned in like September or October. It's been a long time since we've done a lot of that stuff. But I think you guys are actually kind of in a very lucky spot this year because there's a lot of stuff they could put on here that we're not having. So I'd rather just do an integration by parts than have to know all 9 of the have all 9 of the what are those series tests. So this is a lot better. I think you guys lucked out. It stinks, but you lucked out. Yeah, there's no Lagrange. I don't think Lagrange error bounds are part of it. I'll double check. No, yeah. See, Connor doesn't even want to do Lagrange error bounds or the alternating series error bounds. None of those. You guys don't even have to do the Taylor. Remember how we used to do the derivatives of the Taylor polynomials? We don't have to do that. Okay. Polar or parametric wasn't bad, but we hadn't even touched really polar yet, and the polar integration volume, or it's not, they don't even do volume, they only do area, and that stuff is bad. It's ugly. Okay, it's not as bad as series, but it's ugly. So, and it's hard to understand. So I think you guys super lucked out on that. So I would definitely take a good old top minus bottom and a rotation around an axis over polar. So. All right, is there anything else you guys want to see? Because it's your time. But if we're done, we're done, and I'm good with that too. So, but I'm available for another, 14 minutes before I have to go figure out what's for dinner. It's hot dogs. We at least defrosted them. So, I know that much. All right, so nothing else? We're good? Okay, so tomorrow the goal is to go through the one from Tuesday. It really, really helps if you guys have done these ahead of time, okay? Go pull the problems. If you haven't watched the lesson, watch the lesson. They are excellent, okay? And if you don't have a Twitter account, you've got to get a Twitter account and tweet them, because next week we can win t-shirts. And if you win a t-shirt, I win a t-shirt, because they have to send it to me, because they can't send it to your address. So get a Twitter account and start tweeting them. They're going to have instructions on Monday. Okay. All right. Tomorrow we meet at I'm good looking at tomorrow's calendar because I actually have to live by my calendar because I don't have bells anymore. Tomorrow we meet at 1 o'clock. The problem with our regular calc shirts, Connor, I know, I wish we could get them, is their money's trapped in ASB and they can't have ASB meetings. So I can come up with a way to maybe deal with that. I will try, but oh my goodness, why are you wet?
Because we were outside.
Okay, it's not because he peed his pants. Good. So I might be able to come up with something. I don't know. We're getting pretty close on time here, so
Wait, you guys do the Kahoot already?
We did the Kahoot with AB. It's BC right now.
I didn't know that.
No, okay. We've been on here for a long time. Okay. So, but Connor, if we do a shirt next year, I'll make sure you get a calculus shirt next year. Okay. All right. So, any other questions, comments, concerns? We've got like the whole family. Look, there are 6 Ballards in here.
Five.
5. 1,
Andy's
2, 3, 4, 5.
Yes. You're a math teacher, Mom. You need to know how to count.
I'm glad you're counting well.
What? There's 6. Oh, there's 1 missing.
Yeah.
Andy's not here. I'm sorry. There's 5 Ballards in here right now. I see my husband. I think the whole family's here. Okay. All right. So I will see you guys tomorrow. All right. We will and practice do some more calculus. Okay.
Have fun.
All right. Everybody wave. Everybody wave. All right.
So it's like a cheesy thing.
All right. I will see you all tomorrow. Okay. Bye.
Bye. Bye.
Bye. Bye.
Bye. Bye. Bye. Bye. Bye. Bye. Bye. Bye.
Let's go start burning some hot dogs.
Nice.
Come on, let's go.
Delicious.
Come on. Hot dogs.